Alright guys, welcome to Math 0106. In this course we're going to go over the fundamentals of math, and we're going to start today with multiples and divisibility. So a multiple of a number is a product of that number and an integer. So let's look at what this actually means. So what do we mean when we say product? Product means multiplication of a number and an integer. Integers are positive and negative whole numbers. So integers are like -2, -1, 0, 1, 2. Now obviously, we can keep going back. We can say -3, -4, -5. We can keep going forward, 3, 4, 5, right? A lot of times students, when they first hear this, they're like, okay, so the numbers that we know. But numbers can mean a lot of different things. So notice here in this list, we did not include fractions. We did not include decimals. So there you have it. So what do we mean when we say the multiples of 5? Well, we have 5, 10, 15, 20, 25. But what we mean by that, multiples of 5, is what times 5, let me put it this way. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So when we talk about multiples, we're saying what number, when you get multiplied by 1, 2, 3, 4, 5, etc., etc., what are the results? So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, etc., etc. So what I want you to do now, pause the video, and try to do 1 through 6 on your own. And I'm going to assume that you've given it a go, and now we're going to do it together. So what are the first 4 multiples of each number? So what is the first 4 multiples of 2? Well, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So it would be 2, 4, 6, and 8. And this is what we're going to do for each of these. So this is 4 times 1, 4 times 2, 4 times 3, 4 times 4. Now, another thing you should be noticing is that every single time we're just jumping by whatever this number is, because that's what multiples means, right? Like 4 times 2 is 4 plus 4. 4 times 3 is 4 plus 4 plus 4, right? So we could look here, like if you didn't have your, let's say you didn't know how to multiply by 6, well, you just keep adding 6. So that's 12, add another 6, that's 18, add another 6, that's 24. But don't get confused. This still just means 6 times 1, 6 times 2, 6 times 3, 6 times 4. So 8 times what? 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. With 9s, 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Now something that's pretty cool, and from time to time, I will stop you in this video to just illustrate some pretty cool properties. So with 9s, one easy way to look at 9s is if you can count going down, you can deal with 9s. And if you can count going up, you can deal with 9s. So what I hope that you notice is that this is 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, 9 times 7, 9 times 8, 9 times 9, 9 times 10. Nice little easy way to memorize 9s. And the last one is multiples of 10. Well, hopefully that's easy. That's 10, 20, 30, 40. And what I always like to tell students is that knowing how to multiply is extremely important. In your future math classes, you won't be given a calculator. So you're going to need to memorize your multiplication tables. So I'd make that a constant habit. There are ways, obviously, you can get around it. But for the most part, you're going to put yourself at a tremendous disadvantage if you don't learn your multiplication tables. So learn them. Let's move on. Okay, so divisibility rules. So there's a series of divisibility rules, and you're going to want to know these. The first one is divisibility by 2. So what do they say here? Divisibility by 2. A number is divisible by 2 if it has the ones digit is 0, 2, 4, 6, and 8. What that basically means is that if I go to the back digit and as long as it's 0, 2, 4, 6, or 8, these are even numbers, then you know it's evens. I'm sorry, that it's divisible by 2, which does mean even. Okay, so that's a 5. That's not a 0, 2, 4, 6, or 8, so that is not correct. This is an 8, so that would be correct. This is a 0, that would be correct. Because it ends in a 0, the last two ends in a 0 and an 8. That's part of this list right here, so it's legit. So what we're going to do is we're going to go through these divisibility rules, and as we list these divisibility rules, it's in your benefit to try to make sure that you have them memorized. These rules really are beneficial, especially if you don't have a calculator in future classes. Okay, divisibility by 3. So this is one that's pretty cool. A number is divisible by 3 if the sum of the digits is divisible by 3. So all I have to do to see if 54 is divisible by 3 is I'll add 5 and 4. 5 plus 4 is 9. Because 9 is divisible by 3, so is the number. We'll do the same thing with the next one. 4 plus 8 is 12. Because 12 is divisible by 3, it's legit. 9 plus 2 plus 3 is 14. We know 14 is not divisible by 3, so this one is not. So all you have to do is add the digits. If the sum of the digits is divisible by 3, so is the number. The next rule is divisibility by 5. So 5 is very easy. If it ends in a 0 or 5, then it's divisible by 5. So you just have to look at the back and say, hey, does it end in a 0 or 5? Yes. Does it end in a 0 or 5? No. Does it end in a 0 or 5? Yes. And there you have it. Divisibility by 6. So they go through a very detailed process, but this last part is really all that you need to know. To be divisible by 6, it just has to be divisible by 2 and 3. And if you think about that, when you divide any number by 6, what you're really doing is you're dividing the number by 2 and also 3, because 6 is 2 times 3. So all I would have to do is check to see if 945 is divisible by 2 and by 3. So when I look at this, recall what the divisibility rule of 2 is. And the divisibility rule of 2 is if it ends in a 0, 2, 4, 6, or 8, does 5 end in a 0, 2, is 5, 0, 2, 4, 6, or 8? No. Notice I didn't even have to consider 3. I just look at it and I say, hey, does it meet the conditions of what divisibility by 2 means, what even means? It doesn't. I don't even have to care about 3. Okay, so the second one does. It ends in an 8. Okay, so that means it's even. So then I have to add the digits. So we can see here that they went ahead and they did that for us. So 3 plus 4 plus 8 plus 8 is 23. Because 23 is not divisible by 3, it's not sufficient. It has to hold for both of them. Okay, so the last one, yes, it ends in a 0, so that means it's even. 4 plus 2 is 6. Now they do 4 plus 2 plus 0 plus 0, but you don't have to do the zeros. You know, anything plus 0 is just going to be the anything. And so the sum is 6. Now 6 is divisible by 3, right? It is divisible by 3. 6 divided by 3 is 2. So this one is valid. Alright, divisibility by 9. Okay, so 9 is just like 3, except if the sum is divisible by 9. So all you have to do is you add the digits, and if it's divisible by 9, yes, so the number is. Add the digits, is it divisible by 9? No, so the number isn't. Add the digits, is it divisible by 9? No, so the number is not divisible by 9. Last one, super easy. Divisibility by 10 just has to end in a 0. So the only one here that ends in a 0 is 3200. And those are your divisibility rules. Now, is it enough to just listen to what I just discussed for the past 10 minutes? No. You need to go back through. You need to play with these rules. You need to make sure that you really do understand what the rules are. But let's do this. So, pause the video, and I want you to run through and see if you can figure out the answers to the bottom 6. Notice that what you should be doing is with all of this is you should be trying it on your own. If you miss the first question, or if you are tackling the first question and you're like, I don't know how to do it, watch what I do through the first question, then pause the video and see if you can replicate that in the other problems. and just work your way through that way. Okay, so if you're still confused when you tackle number 2 after doing number 1, well, pause the video and watch the video up to through 2 and see if it works. See if it makes sense. Okay, once that makes sense, then try 3 on your own. If you can't do 3, then watch the video, so on and so forth, until you get to the point that you can do these on your own and you're getting the correct answer. So, with that being said, go ahead and pause the video and try to do these problems on your own. I'm going to assume that you've done so. So what I'm going to do is I'm going to write 2, 3, 5, 6, 9, and 10. And I'm just going to cross out for each of these. So, is 34 even? Well, because it ends in a 4, it is. So 2 is correct. Is 34 divisible by 3? We have to add the digits to figure that out and see if the digits are divisible by 3. So 3 plus 4, I guess I'll write this off to the side here. 3 plus 4 is 7, and 7 is not divisible by 3. So this is inaccurate. To be divisible by 5, it has to end in a 5, or 0. It does not. By the way, that also means 10 is gone, and because 3 doesn't work, then 6 doesn't work. Remember, the rule for 6 is that it has to work for 2 and 3. And then the rule for 9 is that the sum of digits is divisible by 9. Now here's the thing, if 3 doesn't work, then 9 doesn't work. Because anything that's divisible by, if it's not divisible by 3, then it can't be divisible by 9. So the only one that works here is 2. Alright, let's look at the next one. So, is 210 divisible by 2? Well, if it ends in a 0, 2, 4, 6, or 8, it is, so hence that is. Is it divisible by 3? Well, 2 plus 1 and plus 0 is 3, because the sum of the digits is divisible by 3, so is the number. So again, all I'm doing here is 2 plus 1 plus 0 gives me 3, and because 3 is divisible by 3, the number is divisible by 3. So 3 works. By the way, 6 is if 2 and 3 both work, then 6 works. 5 is, does it end in a 0 or 5? It ends in a 0, so 5 can work. That's also the rule for 10 if it ends in a 0. Now the divisibility by 9 is just like 3, except it has to be divisible by 9. And because 3 is not divisible by 9, 9 goes away. So, on to number 3, 280. So we're going to write out 2, 3, 5, 6, 9, and 10. And does it end in a 0, 2, 4, 6, 8? Well, yes, it ends in a 0, so that is true. To test for divisibility by 3, 2 plus 8 is 10, because 10 is not divisible by 3, so is the number. By the way, this also, because 2 and 3 are both not correct, that means that 6 is out. With 5, it ends in a 0 or 5, then it's good. It ends in a 5, which also, by the way, because it ends in a 0, means it's 10 is true. And then if 3 does not work, then we know 9 does not work. Or you could simply say 2 plus 8 is 10, and because 10 is not divisible by 9, then the number is not divisible by 9. Okay, we're on to number 4. Now, this is where we start to get into numbers starting to get really big, so let's be careful. Let's write them out. 2, 3, 4, I'm just counting. 2, 3, 5, 6, 9, and 10. So, does it end in a 0, 2, 4, 6, or 8? Yes, it does. So 2 is correct. We're going to add 4 plus 3 plus 8 plus 6. When you add things, or at least when I add things, I'm always looking for the fastest way to add numbers up. So I can put 4 and 6, that's 10. 3 and 8 is 11. So 10 plus 11 is 21. Okay, is 21 divisible by 3? Yes. And since the rule of divisibility by 9 is 21 divisible by 9, no, I can cancel that one out. Also, because 2 and 3 works, I can get to 6. So hopefully as you work through these problems, you start to realize a sort of pattern of how to check very quickly to make sure that it works or it doesn't work. We know that for digits that end in a 6, for it to be divisible by 5, it has to end in a 0 or 5. particularly 6 is not, that's not the case for 6, so 5 is not going to work. And then for 10, it ends in a 0. So that doesn't work. So we'll move on to the next one. And that's going to be, we're going to check for 2, 3, 5, 6, 9, and 10. We're going to do the same process. So does it end in a 2, 4, 6, 8, or 0? No. So we cross this one out. We're going to add the digits. Let me make some space here. So we're going to add 1 plus 4 plus 7 plus 3. Again, I'm going to look for the quickest way. I know that that's 10. I know that that's 5. 10 plus 5 is 15. Not doing anything fancy, right? I may be saying it quickly, but I'm just grouping things in a way that is very easy for me to add. Okay, so 15 divided by 3 is possible. So we're going to include that. By the way, if you got like a really big number and you weren't sure if it was divisible by 3, you could actually repeat the process again, right? If 1 plus 5 is 6, and because 6 is divisible by 3, then that means 15 is divisible by 3, which also means 1,473 is divisible by 3. Kind of a cool little trick. By the way, if the sum is 15, that means 9 is not going to work. Does it end in 5 or 0? Nope. So that means 5's out and also 10's out. And then we also know 6 is out because both 2 and 3 do not work. Okay, on to the last one. So let me write it out. 2, 3, 5, 6, 9, and 10. So let's see here. So does it end in a 0, 2, 4, 6, or 8? Yes, it does. That's true. Let's add the digits. So again, I'm going to, apparently this is my little space to add numbers. So we're going to add 5, or I should say really digits. And what are digits? You guys know what digits are. When you hear digits when you're like at the club and somebody comes up to you and is like, hey, what's your digits, right? So digits are the numbers on your phone, so 0 through 9. So we're going to add these up. And again, I'm going to add these to be efficient. So I know 5, well, let me do this actually. 6 and 4 is 10, right? 8 and 4 is 12, so if I put these two together, that's 22, plus 5 is 27. Okay, it doesn't matter how you do it. You may have looked at this when you did it on your own and did some other combination, but look for easy numbers to put together. Make sure, makes it easier, which also makes it less likely that you're going to make a careless mistake. Cool. All right, so we got 27. So is 27 divisible by 3? Absolutely. By the way, 27 is also divisible by 9. Also, because 2 and 3 works, 6 works. But because this is not 0 and 5, we know 5 and 10 are not going to work. Okay? So if at any point in time you were watching this and you struggled to solve these problems on your own, what I would do is get a blank sheet of paper, rewind it back to the point in the video where the answers are not shown, and rework them on your own and see if you can get there. Get to the answer. Okay, so let's move on. So the next bit that we're going to discuss is prime factorization, and this section starts off with talking about what a factor is. It says a number C is a factor of A if A is divisible by C. It's a little confusing. Let's keep reading. A factorization of A expresses A as a product of 2 or more numbers. Okay, so I always feel like abstraction of math doesn't make sense initially, but when you see an example, it tends to make sense. And so what are factors? The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Why? Because if 24 is divisible by 1, 2, 3, 4, 6, 8, 12, and 24. What this is saying is because if A is divisible, it's a factor if A is divisible by C. So because 24 can be divided by 1, 1 is a factor. Because 24 can be divided by 2, 2 is a factor. So this is what we mean when we say that. Now factorization is when we write it out in such a way as 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6. So what we mean here is we say factorization of A expresses A as a product of 2 or more numbers. So when we write something as a factor, we're breaking it down as what times what times what is the value. Now, what I want you guys to be aware of, It's very, very, very important. What I noticed that students have issues with is in the beginning we talked about multiples. And what happens is when students see multiples, they're like, the definition of multiples, they're like, great, that makes sense. Just the number times 1, times 2, times 3, times 4, times 5. Those are multiples. Then we go to talk about a factor, and you're like, okay, factors, okay, so can I divide 24 by 1, 2, 3, 4, 6, 8, 12, and 24? Yeah, okay, so these are the factors, cool. Factorization, right, as a product. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, that makes sense. But when I throw out all these terms at once, you get confused. So it's very, very, very important that as you are studying these, you really, really, really know what these definitions mean. Now, let's talk more about this, what factors are, okay? So when we talk about the factors of 24, okay, what I recommend doing is you're always going to start with 1, and 1 is always going to be a factor because 1 times anything is the anything, so 1 times 24 is a factor. And then you're literally just going to go count down or count up. So the next one would be 2. So 24 divided by 2 is 12, so that works. 24 divided by 3 is 8, that works. You're seeing that knowing your multiplication tables is very important. 24 divided by 4 is 6, that works. And 24 divided by 5 does not work. 5 does not go evenly with 24, so that doesn't work. So then that's fine, cross it out. 5 doesn't work, we're going to go on to 6. 6. Now you don't actually have to do 6 because 6 is over here. And what's really cool about this is that as we work through, the next one has to be 8. The next one has to be 12, and the last one has to be 24, right? So because we have this sort of flipping effect, it's called the commutative property, because we can flip 1 times 24 and 24 times 1, and they're the same thing. Once you get to the point that you don't have to keep going, you get to the point that you get one of the numbers on the right-hand side, you can stop. Those are your factors. So keep that in mind when you're doing factors. I think that's the easiest way. And then, of course, when I'm doing this, when I'm creating the factors, well, how am I doing it? I'm writing the factorization of 24. Okay, so let's do this. Let's do another example real fast. So let's do something like 24. So let's say I want to write the factorization of 24. So, hold on. That's funny. 24 was the one we just did. I don't want to do that again. Let me choose not 24. Let me do 48. Okay. So what are the prime factorizations of 48? So let me need a little more space. Let's do 48. So what does 48 break down to? Well, again, the factor, we're going to start with 1. So that would be 1 times 48. Then we go to 2 times 24. Then we go to 3 times 16. By the way, this is, for whatever reason, HCC really likes 3 times 16. So if you are doing this course through HCC, I would memorize 3 times 16. I see it all the time for whatever reason. Then we go to 4. 4 is 4 times 12. By the way, some of these are difficult to know, but a lot of these are not. So obviously 1 times 48 is obvious. 2 times 24 you know because of, think of a days, 24 hours a day. So if you're, for example, you're a student, you go days without sleep sometimes. If you don't sleep for 2 days, you've been awake for 48 hours. 3 times 16, that's the one that I would just tell you to memorize. 4 times 12, look, 4 divided by 4 is 1, 8 divided by 4 is 2, so that works. 5 is not going to work. We know, by the way, 5 does not work because it doesn't end in a 0 or 5. We know 6 is going to work because 2 and 3, so something else to take note is our divisibility rules that we've talked about before. They can help us to figure out, hey, does it work or does it work? Does it not work? So 48 is 6 times 8. 7 does not work, and there's really no easy way of doing this other than realizing that, hey, how close can I get to 48? I'm thinking 7 times 7 is 49. So there's no way that that 7 is going to work, because the value would be 7 times 6, which is 42. So I know I'm sounding redundant, but this is why you need to know your multiplication table. So 7 is not going to work. And then we're at 8, so we're done. So these would be the factors, 1, 2. So the factors, let's be clear here, this is the factorization. These are factorizations of 48. But the factors are 1, 2, 3, 4. That is an ugly 4. That is still an ugly 4. 4, there we go. 6, 8, 12, 16, 24, and 48. Fantastic. Okay, let's go back here. Okay, so the next bit is, we're here now. We're talking about what a prime and composite number. So this is very important. A natural number that has two factors, one itself, is called a prime number. So what does that mean? Natural numbers are the numbers that we would consider most natural to us. So natural numbers are, let me write it out here, natural numbers are, and this is usually represented by an n. These are numbers 1, 2, 3, etc., etc. Okay, my penmanship today is not good. Okay, so these are what natural numbers are, 1, 2, 3, 4, the most common numbers. So what we say is a natural number that has exactly two factors, one in itself, is called a prime number. So what that means is prime numbers, down here we have a list of prime numbers. 2 is prime because 2 is only divisible by itself in 1. Okay? 1 and itself. No, 1 we don't consider 1 prime because it's only divisible by, when we say 1 in itself, these have to be unique, so they have to be different than each other. Little sidebar comment about this is that in some forms, some math classes, they will actually say that 1 is prime, but there's a lot of problems that emerge from it. That's why we tend to avoid that case. Okay, 3 is prime because it's only divisible by 3 and 1. Notice 4 is not on the list because 4 is divisible not only by 1 and 4, but also 2 and 2. So it can, the factorization has to only be 1 in itself. The only factors that are work is 1 in itself. Which, by the way, means the only prime number that is, the only even prime is 2. So notice in this list here of the first 100, we do not see any even numbers afterwards. So 5 works, it's only 1 in 5. 7 works. Notice that 9 is not in the list. And the reason why I point that out is one thing that students, if they're seeing this for the first time, that they start to realize in this pattern, they're like, oh, so it's just every odd number. That's not true. Okay, 11 works, 13 works, 15 does not on the list, right? Because 15 is divisible by 5, 17, 19, etc., etc. So there's no easy way to do this, by the way. Like some of these you look at and you're like for example, 97 maybe looks like it'll work, or 89 kind of seems like it would work because it has the 8, which makes you think of 2, and 9, which makes you think of 3. Or 97, I'm thinking to myself, it's just 3 ways, so maybe it's some way or form divisible by 3, but we know that doesn't work because 9 plus 7 is 16, which is not divisible by 3. But there's just something about some of these numbers that makes you think, right? There's no easy way other than just testing them. The cool thing is that if you have your divisibility rules intact, then you can kind of figure out what these are. And in most of the time, we're not going to go beyond 100. So there's maybe some work that you have to do, but usually it's not going to be a lot. And anything that I give is going to be respectable. So we're not going to get probably above like 30 or so. The goal here is to understand what the number is, not to make you painstakingly work through examples. Okay, now, if a number is not prime, we call it composite. So if it's not, other than one that is not prime is called composite. So let me put it this way. If we're talking about natural numbers, right, outside of 1, if it's not prime, then it's composite. So notice if I say it's 1, 1 is neither prime nor composite. If I say 0, well, that's not even part of the list because 0 is not even natural numbers. Okay. Now, I'm just about out of time, so I'm going to stop this video shortly. What I want you to do is try to tackle these problems on your own. And in the next video, we'll start up from here, and we'll see if we can get the answers to these. So on your own, try. By the way, I do realize the list of primes is below, and you could very easily just look at the list and see if it's in there. But cover it up. Try to do it without looking at the list and see if you can figure out what the answers are. In any case, hopefully this first video was enjoyable for you, and I'll find you in the next one.